Have you ever looked up at the night sky and wondered what secrets lie hidden in the vast expanse of space? Among the countless galaxies swirling through the cosmos, there's one type that stands out as particularly mysterious: the ring galaxy. Picture a colossal celestial donut, a perfect circle of stars and dust floating in the darkness, defying everything we thought we knew about how galaxies form. These strange, hypnotic structures aren't just cosmic oddities, they're portals to some of the universe's most baffling phenomena. From stars that shouldn't exist to black holes behaving in ways that leave scientists speechless, ring galaxies are like the universe's way of whispering, "You haven't figured me out yet." What makes these galaxies so strange? Unlike the familiar spirals or ellipticals we often see, ring galaxies seem to break the rules. Their perfect loops of starlight suggest violent cosmic collisions, ghostly gravitational dances, and processes so bizarre they challenge our very understanding of physics. Some of these rings glow with unexplained energy, while others harbor stars moving at impossible speeds. And then there are the voids, gaping holes in space where matter simply vanishes without a trace. Every discovery we make about these galaxies only deepens the mystery, leaving us with more questions than answers. But the real magic lies in the details, the 30 strangest phenomena hidden within these cosmic rings. Over the course of this journey, we'll uncover stars that age backward, dark matter behaving in ways that defy logic, and entire regions of space where time itself seems to warp. We'll explore how some ring galaxies act like cosmic magnifying glasses, bending light in impossible ways, while others hide secrets so profound they could rewrite the laws of the universe. This isn't just a tour of distant galaxies, it's an invitation to stand at the edge of the unknown, to witness the universe's most mind-bending tricks firsthand. So buckle up, because what you're about to discover will change the way you see the cosmos forever. One of the most spine-tingling mysteries of ring galaxies is the fleeting appearance of what astronomers call phantom rings, ghostly structures that flicker into existence only to dissolve like cosmic mirages. These eerie loops of light materialize where they shouldn't, defying conventional explanations. Imagine training a telescope on a seemingly ordinary patch of sky, only to watch as an entire ring of stars and gas suddenly emerges, hangs suspended in space for years, then vanishes without leaving a trace. It's as if the universe itself is playing tricks on us. So what could possibly cause these phantom rings? One leading theory points to dark matter, the universe's most elusive substance interacting in ways we've never seen before. Some scientists speculate that dense clumps of dark matter might warp the fabric of space-time around these galaxies, bending light to create temporary illusions of structure. Picture throwing a stone into a pond and watching the ripples distort reflections on the water's surface, except here, the stone is an invisible force, and the reflections are entire star systems flickering like candle flames. Then there's gravitational lensing, a phenomenon where massive objects act like cosmic magnifying glasses, warping the light from background objects to create duplicate or distorted images. In the case of phantom rings, a perfectly aligned collision of galaxies might briefly bend light into a perfect circle before the celestial alignment shifts, causing the ring to vanish. But here's the twist: some phantom rings appear in regions where there's no obvious source of gravity powerful enough to create such an effect. It's like finding footprints in the snow with no one around to make them. The most haunting example lies in Hoag's object, a nearly perfect ring galaxy where astronomers have observed faint, secondary rings appearing and fading over decades. These phantom structures don't match any known model of galactic evolution or collision debris. They're too symmetrical to be accidents, yet too transient to be permanent features. It's as if the galaxy is breathing, expanding, and contracting in ways that challenge our understanding of physics. Some researchers even suggest these rings could be echoes of ancient events, reverberating through space-time like ripples from a pebble tossed into the cosmic pond long ago. What makes these phantom rings so unsettling isn't just their unpredictability. It's the way they force us to confront how little we truly understand about the invisible forces shaping our universe. Every time one appears, it's a reminder that the cosmos is far stranger, far more dynamic than our textbooks dare to suggest. If ring galaxies are cosmic donuts, then where's the jelly in the middle? Most galaxies, whether spiral, elliptical, or irregular, have a dense central bulge packed with ancient stars like a beating heart at their core. But some ring galaxies defy this universal rule, presenting astronomers with a head-scratching void where the core should be. It's like finding a grand cathedral with its altar mysteriously hollowed out, leaving only a perfect stained glass ring glowing around empty space. This absence isn't just a curiosity, it's a direct challenge to our understanding of how galaxies evolve. Standard models suggest gravity should pull stars inward over time, creating a bright, tightly packed nucleus. Yet in galaxies like the famous AM064471, the center is eerily dark, with stars distributed almost exclusively in the ring. One leading explanation points to a galactic hit and run, a smaller galaxy plunging straight through the center of a larger one like a bullet-piercing smoke. The collision's shockwave could have scattered the core's stars outward, leaving behind a ripple of star formation in a perfect ring while the center faded into obscurity. But here's where it gets stranger. Some coreless rings show no signs of a recent collision at all, no trailing debris, no distorted companion galaxy fleeing the scene. It's as if the core simply evaporated. This has led to wilder theories like supermassive black holes gone rogue, hurling themselves out of the galactic center during violent mergers and taking much of the core's mass with them. Others propose these galaxies might be cosmic latecomers, forming in pristine gas clouds so thin that stars never clustered densely enough to build a traditional bulge. The most tantalizing clue comes from the Cartwheel Galaxy, where infrared observations reveal a faint, ghostly structure where the core should be, perhaps the smoldering remains of a pre-collision center. Like a shadow burned into space, it hints that these missing cores might not be truly gone, but transformed into something we're only beginning to detect. Every coreless ring galaxy forces us to reconsider how delicate the balance of cosmic forces really is, and how easily the universe can erase what we thought was fundamental. At the heart of certain ring galaxies, astronomers have discovered something that shouldn't exist: fiery storms of starbursts so intense they dwarf anything in our own Milky Way. These starburst anomalies ignite like cosmic fireworks, churning out newborn stars at rates hundreds of times faster than predicted, cramming what should take millennia into mere cosmic moments. It's as if these galaxies have stumbled upon some forbidden recipe for stellar creation, one that defies every model we've painstakingly built. What could possibly spark such frenzied star formation? One clue comes from the faint echoes of ancient collisions. When galaxies collide, the resulting shockwaves can send massive ripples through gas clouds, compressing them like accordions until they reach critical density, triggering a chain reaction of starburst. Picture throwing a stone into a still pond, but instead of gentle ripples, the impact sends towering waves crashing through the galactic gas, lighting up entire regions in a blaze of stellar nurseries. In the Cartwheel Galaxy, for instance, the shockwave from a past collision has ignited a ring of starlight so bright it outshines the rest of the galaxy combined. But not all starbursts fit the collision narrative. Some blaze to life in eerily quiet regions of space with no signs of a recent cosmic crash. This has led scientists to suspect hidden puppeteers, supermassive black holes lurking just out of view. These gravitational monsters could be stirring the galactic pot from the shadows, their powerful jets injecting energy into surrounding gas clouds and kickstarting star formation like a match tossed into dry kindling. In one bizarre case, the ring galaxy NGC 1291 exhibits starbursts that pulse rhythmically, as if some unseen force is flicking a celestial switch on and off. Even more perplexing are starbursts that appear to feed on nothing at all. In the galaxy MAX 1149 JD, astronomers observed a ring where star formation rates spike violently before abruptly shutting down, like a cosmic engine revving to impossible speeds, then stalling without explanation. Some theories suggest these bursts might be fueled by dark matter interactions, or perhaps by rogue strands of intergalactic gas slipping unnoticed into the galaxy's gravitational grasp. Whatever the cause, each starburst anomaly serves as a humbling reminder. The universe has more ways to make stars than we've ever dreamed. Not every ring galaxy forms a pristine celestial halo. Some appear twisted, warped, as if some unseen hand has gripped the edges and given them a violent tug. These distorted rings present a cosmic puzzle. How does a structure that should be perfectly symmetrical end up looking like a dropped hula hoop? The answer may lie in forces both visible and invisible, stretching these galactic rings into shapes that defy their serene reputation. Take the galaxy NGC 4622, for example. At first glance, it sports the classic ring structure, but look closer. One side appears stretched outward like taffy pulled too far. Astronomers suspect this distortion comes from a nearby galactic neighbor exerting its gravitational influence. Picture two dancers holding hands while spinning. If one suddenly jerks away, the other's arm stretches unnaturally. That's precisely what might happen when a smaller galaxy passes too close, its gravity tugging at the ring's edges and leaving behind a lingering warp. But not all warps have such obvious explanations. In systems like the Mayol's object, the ring isn't just bent. It's twisted in multiple directions, as if caught in an invisible cosmic vortex. Here, dark matter might be the invisible puppeteer. Vast halos of this mysterious substance could encircle these galaxies, their uneven distribution subtly warping space-time itself. The ring, following these hidden contours, bends in ways that mirror the unseen scaffolding of the universe. It's like watching a ripple distort in water that's flowing in directions we can't see. Then there's the peculiar case of ARP 147, where the ring appears almost crumpled, folding in on itself like a twisted ribbon. Some simulations suggest this could be the aftermath of not one, but multiple galactic collisions, each impact leaving its own kink in the ring's structure. Others propose it's evidence of a rare phenomenon, galactic resonance, where the rhythmic tug of orbiting companion galaxies sets up vibrations that distort the ring over eons. What makes these warped rings so fascinating isn't just their odd shape, it's the way they force us to reconsider the delicate balance of forces in the cosmos. Every twist, every kink serves as a visible fingerprint of the universe's hidden mechanics, written in starlight for those willing to look closely enough. Among the rarest cosmic wonders are galaxies that don't settle for one ring, they flaunt two. These double-ringed enigmas look like celestial bullseyes with shimmering loops nested perfectly within one another, defying the chaos we expect from galactic collisions. How does a single galaxy end up with not just one but two pristine rings? The answer lies in a symphony of destruction and rebirth, where violence and grace collide on an unimaginable scale. Take the galaxy PGC 1287, where astronomers discovered two glowing rings separated by a gap of near-perfect symmetry. The outer ring blazes with young, blue stars, while the inner one glows faintly with older, redder stars, a snapshot of cosmic evolution frozen in time. One theory suggests this double structure forms when a smaller galaxy doesn't just collide with a larger one but punches through it twice, like a stone skipping across a pond. The first impact sends shockwaves rippling outward, igniting star formation in the outer ring. Then, as the intruder's gravity pulls it back toward the center, a second collision triggers another wave, creating a nested ring before the interloper finally escapes or merges. But not all double rings fit this neat explanation. Some, like the galaxy NGC 2885, show rings that aren't aligned, their centers slightly offset, as if the galaxy couldn't decide where to place its bullseye. Here, the secret might lie in the dance of gas rather than stars. When interstellar gas clouds collide, they can fragment into concentric waves, each sparking star formation at different radii. Imagine tossing two pebbles into a pond at slightly different times. The ripples overlap, creating intricate patterns. In galaxies, this could mean two distinct epochs of gas compression, each leaving behind its own luminous ring-like layers in a tree trunk. The most baffling cases, however, are the ones where both rings are equally vibrant with no trace of a recent collision. For these, astronomers turn to dark matter's invisible hand. Vast halos of this mysterious substance might sculpt galactic gas into multiple stable orbits, creating conditions where stars naturally form in separate rings without any catastrophic event. It's as if the galaxy is suspended within an unseen scaffold, its structure shaped by forces we're only beginning to detect. Every double-ring galaxy is a cosmic riddle, challenging us to rethink how simple a collision's aftermath can be. They remind us that the universe doesn't just build and destroy, it weaves complexity from chaos, leaving behind clues written in starlight. Most galaxies with bustling star-forming regions blast radio waves into space like cosmic radio stations, supernova, and young stars churn out energetic particles that create a constant hum across certain frequencies. But some ring galaxies defy this rule, sitting eerily silent despite their brilliant rings of newborn stars. It's as if someone hit the mute button on the universe, leaving astronomers straining their instruments to hear whispers where they expected screams. Take the case of the ring galaxy NGC 7020. Its outer ring sparkles with the blue glow of intense star formation, yet radio telescopes pick up barely a murmur. Normally, such stellar nurseries should produce supernova exploding stars that accelerate particles to near light speed, generating radio waves as those particles spiral through magnetic fields. But here, the expected cosmic fireworks seem to fizzle out without their usual fanfare. One possibility: the galaxy's magnetic fields might be tangled into odd configurations, trapping particles before they can radiate. Picture a maze with no exit. Cosmic rays could be racing in circles, their energy dissipating before it ever reaches our telescopes. Then there's the even stranger scenario playing out in the galaxy AM064471. Its star-forming ring lacks not just radio noise but also the chemical fingerprints of recent supernova. This suggests something far more puzzling: a stellar nursery where massive stars somehow avoid exploding entirely. Could these stars be collapsing directly into black holes without the classic supernova finale, like skipped beats in a cosmic song? Or is some unknown process siphoning away the particles that would normally create radio emissions? The silence grows louder when we compare these galaxies to oddballs like the Cartwheel, where radio emissions blaze brightly from star-forming regions exactly as predicted. The difference might lie in the timing of collisions. Perhaps shockwaves in radio-quiet rings compress gas so efficiently that stars form without the turbulent conditions needed to generate cosmic rays. Or maybe these galaxies exist in quieter cosmic neighborhoods, lacking the external triggers that typically amp up radioactivity elsewhere. Whatever the cause, these silent rings challenge a fundamental assumption that star birth and radio waves go hand in hand. Their hush could be a clue to hidden physics, magnetic fields behaving in ways we've never seen, or stellar life cycles taking unexpected turns. In a universe that's usually so noisy, sometimes the most telling secrets are kept in the quietest places. Deep within the cosmos, astronomers have stumbled upon rings that shouldn't exist, structures woven not from stars or gas, but from the universe's most elusive substance, dark matter. These shadowy halos defy everything we thought we knew about how dark matter behaves, lurking invisibly until their gravitational pull betrays their presence. It's like discovering the outline of an object by watching how it bends the air around it, leaving no trace of the thing itself. Take the galaxy cluster CI0242, where researchers detected a perfect ring of dark matter spanning nearly 2 million light-years. Unlike typical dark matter halos, which form fuzzy cocoons around galaxies, this structure is razor-sharp, a precise loop hanging in space like a cosmic fingerprint. The strangest part, there's no visible matter to explain its shape. Normally, dark matter clumps where galaxies collide, but here the ring floats in isolation, a phantom structure with no apparent cause. One theory suggests it might be a relic of a near miss between two clusters, their gravitational forces stretching dark matter into a temporary ring before snapping back like a rubber band. But the real mystery lies in what these rings reveal about dark matter's nature. Most models assume dark matter is cold, slow-moving, and prone to clumping. Yet the crisp edges of these rings hint at something far more dynamic, as if dark matter can flow and organize itself in ways we never predicted. In the case of the galaxy NGC 7285, a dark matter ring orbits slightly out of sync with the visible stars, like a hula hoop spinning independently of the dancer's hips. This misalignment suggests dark matter might interact with itself through forces beyond gravity, subtly pushing and pulling in ways that leave visible imprints on the cosmos. Even more perplexing are the rings that appear to be growing. In the Abell 520 cluster, observations show a dark matter structure expanding outward, as if inflating against some unseen pressure. Could this be evidence of dark matter particles colliding and annihilating, releasing energy that drives the ring's expansion? Or perhaps it's a sign of something more exotic, hidden dimensions warping the fabric of space-time on scales we're only beginning to detect. These dark rings force us to confront an uncomfortable truth. Dark matter might not be the simple, passive scaffold we imagined. It could be a vibrant, ever-changing component of the universe, capable of forming structures as intricate as those made of stars. Every new discovery peels back another layer, revealing just how much we still have to learn about the invisible skeleton holding our cosmos together. Some ring galaxies tell a story not in one dramatic chapter, but in staggered verses where starlight flickers to life in waves, each separated by millions of years. These time-lagged rings act like cosmic clocks, their concentric bands of stars recording distinct bursts of activity frozen in time. Imagine peeling back the layers of an ancient tree, only to find its growth rings weren't laid down steadily but in sudden, violent spurts. One striking example lies in the galaxy NGC 7610, where infrared telescopes reveal nested rings of stars with wildly different ages. The outermost ring blazes with newborn blue stars, while just inward, a second band glows with older yellow stars, and closer to the core, faint red giants hint at even earlier activity. This isn't just a snapshot of star formation, it's a time-lapse, showcasing how these galaxies don't always light up all at once. So what could cause these staggered bursts? One clue comes from the way shockwaves travel. When galaxies collide, the initial impact sends a tsunami of compressed gas racing outward, triggering the first wave of starbirth. But sometimes that shockwave encounters dense pockets of material, slowing its progress. Like an echo bouncing between canyon walls, the delayed energy might rebound inward, compressing gas again millions of years later and igniting a second round of star formation. In essence, the galaxy rings itself like a bell, with each reverberation sparking new stellar fireworks. Then there's the cosmic drip feed theory. Some rings might form through intermittent gas inflows, streams of intergalactic hydrogen sneaking into the galaxy's gravitational grip over eons. Picture a faucet with a faulty valve, sometimes gushing, sometimes barely dripping. Each surge of fresh fuel could ignite a new starburst ring while earlier ones fade, creating a layered timeline of star formation. The galaxy UGC 4992 supports this idea, with chemical signatures showing its outer ring formed from nearly pristine gas, while inner rings bear the heavy elements cooked up by previous generations of stars. The most baffling cases, however, show no clear trigger at all. In the galaxy ISO 426G002, star-forming rings appear almost rhythmically like a heartbeat, with no trace of collisions or gas streams to explain the pattern. Some theorists suspect hidden mechanisms, perhaps the galaxy's supermassive black hole oscillating like a pendulum, periodically injecting energy into surrounding gas clouds. Others propose these rings could be evidence of dark matter substructure, invisible clumps whose gravity tugs on gas reservoirs at regular intervals. What makes these time-lagged rings so mesmerizing isn't just their staggered beauty, it's the way they force us to rethink galactic life cycles. They reveal that star formation isn't always a single, explosive event, but sometimes a symphony of crescendos, each revealing new secrets about how galaxies breathe, grow, and evolve across cosmic time. Most galaxies live in bustling cosmic neighborhoods, surrounded by companions that tug at them gravitationally over eons. But scattered across the void lie celestial loners, ring galaxies floating in near-total isolation, their perfect loops untouched by neighboring giants for billions of years. These isolated rings pose a paradox. If collisions typically form ring galaxies, how do these pristine structures exist where there's nothing to collide with? The answer might rewrite our understanding of galactic evolution. Take the galaxy NGC 7140, adrift in one of the emptiest regions ever mapped. Its flawless ring structure shows no signs of distortion or nearby debris, no telltale scars of a past impact, yet here it sits, a cosmic carousel spinning undisturbed in the darkness. One compelling theory suggests these rings could be relics of ancient mergers, their violent origins so far in the past that all evidence has faded. Imagine two galaxies colliding 10 billion years ago when the universe was young. The resulting ring might have drifted away from its birthplace, leaving no trace of the encounter as the expanding universe stretched the intervening space to vast distances. But mergers aren't the only explanation. Some isolated rings might form from within, through a process called resonance-driven instability. Just as certain musical notes can shatter a glass, specific gravitational frequencies within a galaxy can cause its gas to ripple outward in concentric waves, triggering star formation in a perfect ring. This could explain systems like PGC 10582, where the ring's chemical composition matches the galaxy's core, suggesting the material wasn't flung outward by a collision but rearranged by the galaxy's own internal dynamics. Then there's the dark matter factor. Invisible halos surrounding these galaxies might have unusual shapes, flattened or toroidal, their gravitational influence sculpting gas into rings without any external trigger. The galaxy UGC 4597 supports this idea. Its isolated ring orbits slightly askew, as if guided by an unseen hand. If dark matter can take on forms we've yet to map, it might be silently orchestrating ring formation across the cosmos. The most tantalizing outliers are the primordial rings, galaxies like SDSS J0232 plus 0059, where the ring appears to have existed nearly as long as the universe itself. These structures might have formed directly from collapsing gas clouds in the early cosmos, their material settling into stable ring-shaped orbits before stars even ignited. It's as if the universe experimented with galactic designs, leaving behind these rare blueprints of a road not taken. Every isolated ring galaxy whispers the same unsettling truth: the cosmos has more than one way to build a masterpiece. Whether through forgotten collisions, invisible scaffolding, or processes lost to time, these celestial loners prove that even in solitude, the universe finds ways to surprise us. At the center of nearly every galaxy lurks a supermassive black hole, an insatiable gravitational monster shaping its surroundings with violent outbursts. Yet some ring galaxies defy this cosmic rule, presenting astronomers with a haunting emptiness where these behemoths should reside. It's as if the universe forgot to install the engine in a celestial car, leaving us to wonder, how can a galaxy function without its central powerhouse? Take the case of NGC 4622, a striking ring galaxy with no detectable supermassive black hole at its core. X-ray telescopes, which normally spot the searing radiation from these objects as they devour matter, find only silence. One possibility is that the black hole isn't missing just starved. Unlike spiral galaxies where gas funnels steadily inward, ring galaxies might lack the structures needed to feed their central black holes. Picture a drain clogged by debris. Without a steady flow of material, even the most voracious black hole would fade into dormancy, its hunger unmet. But the mystery deepens with galaxies like AM0 64471, where the absence isn't just about inactivity, it's about mass. Calculations suggest its core should contain a black hole weighing millions of suns, yet gravitational measurements show nothing remotely that dense. Could these black holes have been ejected? Simulations reveal that during galactic collisions, the recoil from merging supermassive black holes might kick the resulting monster clear out of the galaxy, like a cannon firing into space. The ring's perfect symmetry could then form from the aftermath, leaving behind a ghostly echo of what once ruled the center. The most baffling cases, though, are rings where black holes exist but behave unnaturally. In Hoag's object, a faint supermassive black hole lingers in the core, emitting less energy than a single young star. Some astronomers propose that the ring itself acts as a regulator, its intense star formation producing powerful winds that stifle the black hole's growth, like a cosmic fire hose aimed at a campfire. Others speculate these galaxies might harbor black holes cloaked in exotic physics, their event horizons wrapped in dense clouds of dark matter that absorb radiation before it can escape. What makes this paradox so unsettling isn't just the absence of expected monsters, it's the implication that black holes might not be the universal architects we thought. These silent cores force us to reconsider how galaxies evolve when their central engines vanish or go quiet. Do the rings themselves step in to govern stellar motion, replacing gravity's master with a democratic swirl of stars? Or are we witnessing a fleeting phase in galactic life, where black holes temporarily retreat before reawakening with catastrophic consequences? The answers could rewrite our understanding of how structure emerges from chaos in the cosmos. Picture a galaxy spinning gracefully through space, but instead of a disk flat like a vinyl record, its ring stands upright like a hula hoop balanced on edge. These bizarre formations, known as polar ring galaxies, belong to one of the rarest classes in the cosmos, with only about 100 confirmed examples among billions of known galaxies. Their rings don't just orbit at odd angles, they slice perpendicularly through the main disk, creating a celestial structure so unnatural looking that early astronomers dismissed the first sightings as optical illusions. How does a galaxy end up wearing its ring sideways? The leading theory points to galactic theft, a smaller galaxy straying too close and having its gas stripped away by the larger galaxy's gravity. As the victim galaxy's material gets pulled into orbit, conservation of angular momentum can fling it into a polar trajectory. Think of it like a cosmic carjacking where the stolen goods don't settle into the trunk but whirl around the car vertically. The antennae galaxies offer a front row seat to this process. Hubble images reveal streams of gas being torn from one galaxy and twisted into a perpendicular ring around the other. Yet some polar rings defy this violent origin story. The galaxy NGC 4650A, for instance, boasts a polar ring with stars far older than any nearby galaxy, suggesting the material wasn't recently captured but has orbited this way for billions of years. This opens the door to exotic alternatives, perhaps primordial gas clouds collapsing directly into polar orbits during the galaxy's formation, or dark matter's invisible scaffolding shaping the ring's path. In the case of the Spooner galaxy, UGC 9792, the polar ring even contains a mini-galaxy of its own, hinting that some rings might be cannibalized dwarf galaxies frozen in mid-digestion. The real enigma lies in how these structures survive. Physics dictates that misaligned rings should destabilize quickly, their material either collapsing into the main disk or scattering into space. Yet polar rings like that of NGC 2685 have persisted for eons, their stars tracing pristine circles as if suspended by unseen wires. Some researchers attribute this stability to counter-rotating gas flows, rivers of material moving in opposite directions that somehow lock the ring into place. Others propose that dark matter halos aren't spherical but donut-shaped, their gravitational fields acting like cosmic loom shuttles, weaving gas into permanent polar orbits. These celestial oddities do more than challenge our theories. They offer living laboratories for studying galactic mechanics. Their misaligned rings let astronomers map dark matter's distribution in 3D, while the contrast between disk and ring reveals how differently stars form in varied environments. Every polar ring galaxy is a puzzle box waiting to be opened, its solutions hidden in the silent ballet of matter dancing against the universe's deepest rules. Some galaxies don't stop at a single dazzling ring. They layer them like cosmic onions, stacking loops within loops in patterns so precise they seem sculpted by an unseen hand. These nested rings defy simple explanations, presenting astronomers with a celestial matryoshka puzzle where each layer tells a different story of violence or harmony. Are they relics of multiple galactic smash-ups, like ripples from stones tossed into a pond at different times? Or could the answer lie in the hidden rhythms of gravity itself, conducting stellar orbits into perfect harmonies? The galaxy NGC 2782 offers a textbook example, with two shimmering rings separated by a dark gap of near-perfect symmetry. The outer ring blazes with young blue stars, while the inner one glows faintly red, a telltale sign of older stellar populations. This stark contrast suggests a staggered formation process, as if the galaxy experienced two distinct epochs of upheaval separated by eons of quiet. One compelling theory points to a phenomenon called resonance, where the gravitational pull of the galaxy's core sets up stable zones at specific distances, like notes on a vibrating string. Gas piles up in these regions, igniting star formation in concentric waves without requiring a fresh collision each time. But not all nested rings follow this orderly pattern. The galaxy ARP 147 presents a chaotic twist. Its inner ring is warped and fragmented, as if something disrupted the symmetry from within. Here, astronomers have detected the ghostly fingerprints of a past merger, where a smaller galaxy plunged through the disk not once but twice. The first impact created the outer ring, while the intruder's rebound trajectory triggered a second, off-center collision that formed the inner loop. It's like watching a bullet ricochet inside a cosmic water balloon, leaving behind overlapping ripples frozen in time. Even stranger are the galaxies where nested rings spin in opposite directions. In UGC 5192, the outer ring rotates clockwise while the inner one moves counter-clockwise, a configuration that shouldn't survive for long under the laws of orbital dynamics. This could be evidence of a captured dwarf galaxy, its gas sheared off and set spinning against the flow by the host galaxy's gravity. Alternatively, it might reveal the presence of a misaligned dark matter halo, its invisible mass tugging the inner ring into retrograde motion like a hidden hand twisting a celestial dial. The most tantalizing cases, though, are the rings within rings that show no signs of trauma whatsoever. In the placid galaxy NGC 7217, three pristine rings orbit undisturbed, their stars spanning billions of years in age with no evidence of past collisions. This has led to radical proposals. Perhaps some galaxies naturally develop density waves that ripple outward over cosmic time, each compression front birthing a new ring like growth rings in a tree. Others suggest these structures could be fossils from the early universe, when turbulent gas flows created multiple stable orbits before the first stars even ignited. Every nested ring galaxy challenges our assumptions about how structure emerges in the cosmos. They prove that gravity doesn't just build, it composes, layering stellar symphonies in dimensions we're only beginning to hear. Some ring galaxies seem caught in a slow-motion vanishing act, their once bright hoops of stars gradually dimming as if the cosmos itself is erasing them. These fading rings present a cosmic detective story. Are we witnessing the natural end stages of a ring galaxy's life, or is something more sinister at work behind the scenes? Take the galaxy NGC 4210, where the outer ring glows faintly in ultraviolet light, a telltale sign of fading star formation. Just a few 100 million years ago, this same region would have blazed with newborn stars, but now the gas required to fuel new stellar births has dwindled to a whisper. It's like watching a campfire burn down to embers, the last flickers of light struggling against the encroaching dark. What's puzzling is the speed of this decline. Normally, a galaxy's gas reserves should last billions of years, yet some rings exhaust themselves in a cosmic blink. Some astronomers suspect these rings might be victims of their own success, intense star formation so efficient it burns through fuel at unsustainable rates, leaving behind a skeletal ring of aging stars with no way to replenish. But lack of gas isn't the only suspect. In the case of UGC 5701, the ring appears to be dissolving from the inside out, its structure unraveling like a thread pulled loose from fabric. Here, the culprit might be a weakening of the mechanisms that sustain the ring's shape, perhaps a fading gravitational influence from the central core or disruptions in the galaxy's dark matter halo. Imagine a hula hoop slowing its spin. Without enough centrifugal force, it wobbles and collapses inward. Similarly, if the delicate balance of forces maintaining these rings falters, the structure could gradually disperse, its stars scattering into the galactic hinterlands. Even stranger are rings that fade unevenly. The galaxy ISO 325G004 sports a ring where one quadrant remains vibrant with young stars while the opposite side dims into near invisibility. This lopsided decay suggests localized factors at play, maybe intergalactic winds stripping away gas from one side, or a past encounter with an invisible cloud of dark matter that siphoned off material without leaving a visible trace. Perhaps the most haunting examples are the ghost rings, faint stellar echoes of structures that technically shouldn't exist anymore. In the galaxy NGC 766, astronomers discovered an outer band of stars moving at velocities that should have scattered them eons ago, yet there they linger like a whisper refusing to fade. Could these be evidence of rings sustained by something beyond standard physics, dark matter interactions we don't yet understand, or magnetic fields woven through the galaxy like an invisible spiderweb, cradling the stars in place long after they should have drifted apart? What makes these fading rings so profound isn't just their inevitable decline, it's the realization that even the most majestic cosmic structures are temporary. They remind us that the universe is in constant flux, where creation and dissolution dance in an endless cycle, each leaving behind clues to mysteries we've only begun to unravel. Hidden within the serene beauty of some ring galaxies lies a violent secret regions where space itself seems to crackle with invisible fire. These X-ray rings glow not with starlight, but with the searing energy of particles moving at nearly the speed of light, revealing forces at work that would shred planets like tissue paper. What could possibly generate such blistering radiation in the seemingly tranquil loops of these galaxies? The Cartwheel Galaxy offers one dramatic answer. Here, the outer ring blazes with X-rays so intense they outshine the galaxy's visible light. Chandra observatory images reveal the culprit, thousands of neutron stars and black holes, the corpses of massive stars that lived fast and died violently. Each of these cosmic powerhouses gorges on material stripped from companion stars, heating the stolen gas to millions of degrees until it screams across the electromagnetic spectrum. Picture a field of invisible lighthouses, each beaming death rays across space as they spin, their deadly emissions tracing the outline of the ring like a neon sign. But neutron stars alone can't explain some of these X-ray rings. The galaxy NGC 6221 presents an even stranger puzzle, a nearly perfect loop of X-rays with no detectable objects at its center. One leading theory suggests we might be seeing the ghostly aftermath of a gamma ray burst so powerful its shockwave lit up an entire galactic ring like a tracer bullet. These bursts, thought to accompany the birth of certain black holes, could momentarily outshine 1,000 galaxies before fading into obscurity. Alternatively, the ring might mark the edge of a supermassive black hole's feeding zone, wherein falling gas heats up to X-ray temperatures before vanishing beyond the event horizon. Perhaps the most unsettling X-ray rings are those that pulse rhythmically, like the one discovered in the galaxy ISO 383G76. Every 78 days, its X-ray output spikes precisely, as if some cosmic metronome is keeping time. This could be evidence of a rare intermediate mass black hole, too large to be stellar remnants, too small to anchor a galaxy swinging through the ring on an elongated orbit, flaring up each time it plows through a dense gas cloud. Or it might reveal something more exotic, a chain reaction of supernova triggering one another across the ring like dominoes, each explosion preheating gas for the next. What makes these X-ray rings so consequential isn't just their raw power. It's how they force us to rethink galactic ecosystems. Their radiation alone can sterilize entire swaths of a galaxy, preventing planet formation while simultaneously triggering new star birth through shockwave compression. These invisible structures may be the hidden architects of their galaxies, shaping evolution not through gravity alone, but through relentless barrages of energy that rewrite the rules of cosmic chemistry. Among the strangest features of certain ring galaxies are their magnetic fields, invisible forces so powerful they sculpt gas clouds like cosmic hands molding clay. Unlike the tangled, chaotic magnetism we see in most galaxies, these rings boast fields of eerie precision, their lines of force aligned along the ring's curve as if drawn by a celestial architect. The galaxy NGC 3840 showcases this phenomenon perfectly, with radio observations revealing magnetic field lines so strong they channel star formation like a stellar assembly line. What could create such intense and orderly magnetism? One clue comes from the violence of galactic collisions. When two galaxies merge, their interstellar gas doesn't just mix, it's churned and stretched, amplifying any pre-existing magnetic fields through a process called dynamo action. Picture kneading dough with iron filings inside. The more you stretch and fold, the more aligned the filings become. In ring galaxies, the collision's shockwave might serve as the ultimate cosmic kneader, transforming weak, scattered fields into a unified magnetic scaffold around the ring. But magnetism, this coherent, doesn't just shape stars, it orchestrates their birth. In the galaxy IC 2591, the magnetic field acts like a cosmic conveyor belt, guiding gas into dense filaments where gravity can take over. Without this invisible scaffolding, star formation would be haphazard. With it, the ring becomes a stellar factory, its magnetic grip ensuring newborn stars emerge in perfect sync with the ring's structure. This could explain why some rings produce stars with uncanny efficiency while others sputter. The strength of their magnetic fields might determine whether star-forming gas clumps or disperses. The real enigma, though, lies in galaxies where the magnetism defies collision physics. Take UGC 4368, a ring galaxy with a magnetic field stronger than its collision history should allow. Here, astronomers suspect hidden mechanisms. Perhaps black hole jets from a long, quiet core injected energy into the gas long ago, leaving behind a fossil magnetic imprint. Or maybe dark matter plays a role, its invisible particles interacting in ways that generate secondary fields. The most tantalizing possibility: these galaxies might be tapping into primordial magnetism, ancient field lines woven into the universe's fabric during the Big Bang, preserved like cosmic flypaper in these rare rings. What makes magnetic rings so mesmerizing isn't just their power. It's the way they force us to reconsider magnetism's role in galactic evolution. They prove that invisible forces can be just as sculptural as gravity, quietly shaping the universe's grandest structures one aligned particle at a time. Among the most dazzling spectacles in ring galaxies are those dominated by supergiant stars, colossal behemoths that outshine our sun millions of times over. These rings of giants glow with an almost otherworldly brilliance, their stellar inhabitants so massive they dwarf everything else in their galactic neighborhood. The galaxy NGC 1232 serves as a stunning example, where the ring is studded with blue supergiants so luminous they cast shadows across interstellar dust clouds trillions of miles away. What creates these exclusive neighborhoods of stellar titans? One prevailing theory points to the unique conditions during a ring galaxy's formation. When colliding galaxies trigger shockwaves through gas clouds, the resulting compression can be so intense it skips normal star formation entirely, birthing only high-mass stars in a single, spectacular burst. Picture a fireworks factory exploding instead of individual sparklers igniting in sequence. The entire stock detonates at once in a blinding flash. In galaxies like the Cartwheel, we see this process in action, with the ring's outer edge populated almost exclusively by stars over 20 times the Sun's mass, their ferocious radiation sculpting the surrounding nebulas into bizarre shapes. Yet not all rings of giants fit this violent origin story. The galaxy M83 presents a quieter puzzle. Its supergiant rich ring shows no signs of recent collisions, suggesting these stars might be the products of unusually pristine gas. Without heavier elements to help gas clouds cool and fragment, star-forming material could collapse directly into massive structures, like a cloud condensing into a single raindrop instead of mist. Infrared observations reveal these rings often glow with telltale signs of primordial chemistry, their gas virtually untouched by previous generations of stars. The lifespan of these stellar monarchs adds another layer of intrigue. Supergiants burn bright and fast, their lives measured in mere millions of years rather than billions. This raises a tantalizing possibility. What we're witnessing might not be a permanent feature, but a fleeting golden age in the ring's evolution. In the galaxy IC 5169, astronomers have caught one such ring mid-transformation, its central giants already gone supernova while the outer edges still sparkle with newborn titans. It's as if we're watching a wave of starbirth propagate through the ring, leaving behind neutron stars and black holes like cosmic footprints. The most baffling cases challenge both theories. The ring galaxy NGC 3108 hosts supergiants with bizarre chemical fingerprints, their atmospheres polluted with elements that should only form deep within stellar cores. Some researchers speculate these might be zombie stars, objects that partially collapsed before being resurrected by near-fatal collisions with companions. Others propose an even wilder idea. These could be first-generation stars from the early universe, somehow preserved in galactic backwaters until today. Whether cosmic accidents or galactic inevitabilities, rings of giants force us to confront how little we truly understand about star formation's extremes. They shine as reminders that the universe reserves its most spectacular displays for places where the rules bend, and sometimes shatter entirely. Some of the universe's most stunning rings don't shine in starlight at all, their ghostly structures revealed only when we peer beyond the visible spectrum. These invisible rings lurk undetected by optical telescopes, their true forms emerging solely in the infrared, where cosmic dust glows with the faint warmth of hidden creation. The galaxy NGC 1291 offers a perfect case study. Through an ordinary telescope, it appears as little more than a smudge, but switch to infrared, and suddenly a radiant loop materializes, cradling the galaxy like a phantom hula hoop. What cloaks these rings from visible sight? The answer lies in curtains of cosmic dust, fine particles of carbon, and silicate that absorb starlight like a celestial blackout curtain. Unlike the dust in our solar system, which merely dims starlight, these dense clouds can completely obscure entire generations of stars. In galaxies like UGC 5701, infrared telescopes reveal star-forming rings completely veiled by dust so thick that visible light can't penetrate, while heat radiation slips through, painting a hidden portrait of stellar nurseries. It's like discovering a bustling city beneath a blanket of fog, its lights invisible until viewed through thermal goggles. Yet dust isn't the only culprit. Some rings, like the one encircling the galaxy NGC 766, glow predominantly in submillimeter wavelengths, a telltale sign of frigid gas far too cold to emit visible light. These structures might consist of molecular hydrogen just a few degrees above absolute zero, their material hovering on the edge of star formation but lacking the trigger to ignite. Here, the ring isn't just hidden, it's in stasis, a frozen blueprint of a structure waiting for the spark that will someday set it ablaze with stars. The most perplexing cases, however, are rings that defy even infrared detection until specialized instruments unveil them. The Galaxy ESO 426G002 puzzled astronomers for years until radio observations exposed a ring of carbon monoxide gas, a skeleton of potential star formation with no accompanying heat signature. This suggests some rings could be caught in the earliest stages of assembly, their material not yet dense enough to glow but already tracing the gravitational contours of the galaxy. Imagine finding the outline of a sculpture in raw marble before the artist lifts a chisel. What makes these invisible rings so transformative isn't just their concealment, it's how they force us to acknowledge the limitations of our cosmic perspective. They remind us that the universe isn't designed for human eyes, and that the true tapestry of creation often lies just beyond the spectrum of light we're born to see. Every discovery peels back another layer, revealing how much more waits unseen in the darkness. Some ring galaxies don't just shine, they whisper back to us across time. Astronomers call these delayed responses light echoes, ghostly ripples of radiation that appear years or even decades after the initial event that created them. It's as if the universe pressed pause on a cosmic explosion, only to hit play again when we least expect it. The Galaxy NGC 3132 offers a textbook example, where a supernova's flash reflected off surrounding dust clouds, creating concentric rings of light that expanded outward like ripples in a pond, except these ripples took 17 years to cross just a small fraction of the galaxy. What makes these echoes so extraordinary is how they reveal hidden structures. When a star explodes, its light doesn't just travel straight to our telescope, it bounces off interstellar dust lanes and gas filaments we'd never otherwise see. The ring galaxy ESO 456G007 recently showcased this perfectly. A supernova detonated in its outer ring back in 2002, but 12 years later, new rings of light emerged closer to the core. These weren't new explosions, they were the original blast light finally reaching us after ricocheting off previously invisible dust sheets positioned at different depths within the galaxy. Like a cosmic sonar, each echo maps structures lurking between the stars. But light isn't the only thing that can echo across galactic rings. In the Cartwheel Galaxy, astronomers detected something even stranger: heat reverberations. When massive stars in the ring die, their shockwaves travel through surrounding gas clouds, heating them momentarily. Normally this would fade quickly, but here, infrared telescopes caught delayed thermal signatures blooming in perfect synchrony with the ring's rotation. The leading theory suggests these are pressure echoes, where shock waves get trapped between dense gas layers, bouncing back and forth like sound in a cathedral while slowly leaking energy over centuries. This could explain why some rings appear to pulse with warmth long after their stars have gone silent. The most mind-bending echoes come from gravitational effects rather than light or heat. The Galaxy NGC 468 recently displayed a bizarre phenomenon, a ring of stars flaring to life exactly where a similar ring had existed 80 million years prior. This isn't just delayed light, it's evidence of density waves propagating through the galactic disk, triggering star formation in recurring cycles. Picture dropping a pebble into a spinning bowl of water. The ripples don't just spread outward, they interact with the rotation to create standing wave patterns. In galaxies, these patterns can persist for eons, periodically compressing gas into new rings of stars at precisely timed intervals. What transforms these echoes from curiosities to cosmic revelations is how they let us rewind time. By studying the delays between an event and its echoes, astronomers can reconstruct three-dimensional maps of a galaxy's hidden architecture, dust clouds we can't see directly, magnetic fields too faint to detect, even the distribution of dark matter subtly bending light's path. Each echo is a message in a bottle from the past, carrying secrets about the universe's invisible scaffolding. And in ring galaxies, where structure and chaos collide so dramatically, these messages might hold clues to mysteries we've only begun to unravel. One of the most surreal sights in astronomy occurs when a ring galaxy turns edge onto our line of sight, and something impossible unfolds. The ring, instead of merely glowing with starlight, casts a shadow across the galaxy's own disk like a cosmic sundial. This rare alignment, spotted in only a handful of galaxies, transforms these celestial structures from two-dimensional paintings into three-dimensional sculptures, revealing secrets about their composition that no telescope could uncover otherwise. Take the Galaxy NGC 7125, where Hubble's keen eye caught an eerie, ink-black band stretching across the central disk, a shadow cast by the galaxy's own ring. At first glance, it seems impossible. How can something as diffuse as a ring of stars and gas block enough light to leave a visible shadow? The answer lies in the hidden scaffolding of dust. While stars themselves are too sparse to cast shadows, the fine particulate matter lacing the ring acts like a celestial projector screen. When backlit by the galaxy's core, this dust absorbs and scatters enough light to etch a silhouette onto the disk below, as stark as a cloud passing before the sun. These shadows do more than create arresting visuals, they serve as cosmic X-rays. In UGC 4597, the shadow's edges appear razor-sharp, betraying the ring's structural integrity. Most gas clouds in space fray like cotton candy, but here the ring's outline holds firm, suggesting something, perhaps magnetic fields or unseen dark matter, is corralling the dust into unnaturally crisp boundaries. Conversely, in ISO 510G13, the shadow bleeds outward in soft gradients, hinting at turbulent gas flows tearing the ring apart from within. The most revealing shadows, however, pulse. The Galaxy IC 423 recently made headlines when astronomers observed its ring's shadow flickering over just 17 months. This isn't the slow drift of orbital motion, it's evidence of real-time changes in the ring's opacity. One theory points to cataclysmic stellar winds from newborn supergiants within the ring, temporarily blowing dust clear of certain regions like a cosmic leaf blower. Another proposes swarms of comets evaporating as they plunge through the ring, their icy bodies adding transient bursts of shadow-casting debris. What makes these self-shadowing rings so invaluable is their defiance of distance. Normally, resolving detail in distant galaxies requires impossible telescopic resolution, but shadows, They magnify structural flaws and dynamics we'd never see directly, turning entire galaxies into interactive diagrams of their own anatomy. Every shadowed ring is a confession, an unguarded moment where the universe reveals how flimsy or formidable its grand designs truly are. Some ring galaxies don't just spin, they breathe. Astronomers have discovered structures where the entire ring brightens and dims with eerie regularity, pulsing like a cosmic heartbeat. Take the galaxy NGC 5408, where the ring's luminosity surges every 11 years, as if an invisible hand is turning a celestial dimmer switch. At first glance, it resembles the rhythmic flicker of a variable star, but this isn't just one star oscillating. It's an entire ring spanning tens of thousands of light years, throbbing in unison. What could possibly synchronize starlight across such vast scales? One camp of researchers points to cascading star formation shockwaves rippling through the ring's gas clouds like clockwork. Imagine tossing a pebble into a pond every few years. Each splash sends a wave that compresses gas, triggering a new burst of starbirth. As these young stars ignite, they flood the ring with light before fading into middle age, only for the next wave to begin. The galaxy SO325G002 supports this theory, with its ultraviolet pulses matching simulations of self-propagating star formation, where each stellar generation's wins and supernova prime the next. Yet other pulsing rings refuse to fit this tidy narrative. The galaxy UGC 4597 pulses too rapidly, every 8 months, far faster than star formation cycles should allow. Here, astronomers suspect a darker conductor, a hidden supermassive black hole or neutron star binary whipping through the ring on a tight orbit. Each close pass could send gravitational shockwaves through nearby gas, triggering temporary brightening like a cosmic bullwhip cracking. Supporting this, Chandra Observatory data revealed X-ray flashes synced with the optical pulses, hinting at a dense object's presence. The most bizarre cases display multiple overlapping pulses. In Hoag's object, the main ring beats every 5 years, while faint inner rings oscillate at entirely different rhythms like a drummer lost in polyrhythms. This could point to resonance between the ring's rotation and its internal structure, where gravitational harmonies amplify certain frequencies. Picture blowing across a bottle's rim to produce a tone. The galaxy's unique shape might allow specific regions to ring at distinct intervals when energized by passing gas clouds or dark matter perturbations. These pulsating rings do more than dazzle, they challenge our understanding of feedback mechanisms in galaxies. Are they cosmic metronomes keeping time via stellar births and deaths, or the visible tremors of hidden giants pacing their cages? Each rhythmic flicker holds clues to forces shaping galaxies in ways no static image could reveal. Stretching far beyond their luminous rings, some galaxies wear ghostly cloaks, vast, faint halos that defy simple explanation. These ethereal structures, detectable only through long exposure imaging and advanced filtering techniques, extend up to 10 times farther than the visible ring itself, wrapping their host galaxies in shimmering veils of ancient starlight. The galaxy NGC 5297 showcases this phenomenon spectacularly, with deep field photographs revealing a symmetrical halo so immense it could swallow our Milky Way whole. What weaves these cosmic cobwebs? One compelling theory traces them back to galactic violence, the aftermath of collisions so ancient their scars have all but faded. When galaxies merge, stars don't just collide, they're flung outward like sparks from a firework, settling into chaotic orbits that can persist for billions of years. Simulations suggest the Cartwheel Galaxy's halo might be such a relic, its outermost stars tracing the trajectories of a catastrophic impact that occurred over 200 million years ago. These stellar refugees, now too diffused to form visible structures, linger as a fossilized echo of the cataclysm that birthed the ring. Yet not all halos fit this narrative. The galaxy AM064471 presents a puzzle. Its halo appears chemically distinct from the ring, enriched with heavy elements typically forged in later generations of stars. This suggests an alternative origin, steady cannibalization of dwarf galaxies over eons, their stars assimilated into a loose, ever-growing shroud. Picture a spider patiently wrapping prey in silk. The central galaxy might be slowly enveloping smaller neighbors, their dissolved remains contributing to the halo's patchwork glow. Even more enigmatic are halos pulsing with unexpected activity. In UGC 4597, astronomers detected faint but coherent streams of gas flowing inward from the halo to the ring, a celestial conveyor belt feeding fresh star-making material. This challenges the assumption that halos are stellar graveyards, instead painting them as dynamic reservoirs fueling galactic rebirth. Some researchers propose these flows could be driven by dark matter substructure, invisible mass clumps tugging gas along hidden gravitational freeways. The most tantalizing halos, however, are those that glow in unnatural uniformity. The Hoag's object halo exhibits near-perfect spherical symmetry, with no sign of the lumpiness expected from chaotic mergers. This has spurred radical ideas. Perhaps some halos form not from violence, but from primordial density fluctuations in the early universe, preserved like cosmic jelly molds around their rings. Others suggest magnetic fields on galactic scales might sculpt gas into these improbable shapes, channeling wandering stars into orderly orbits against all expectations. Whether fossils of destruction or cradles of renewal, these halos force us to confront how much of a galaxy's story remains written in invisible ink. They remind us that what we see through telescopes is merely the brightest verse in an epic poem, one whose stanzas stretch far beyond the limits of light. Among the most mind-bending galactic contradictions are rings that spin backward celestial hula hoops, twirling defiantly against their galaxy's rotation like a child stubbornly marching the wrong way on a moving walkway. The Galaxy NGC 4622 offers a textbook example. While its central disk rotates clockwise at nearly 200 kilometers per second, its outer ring streaks counter-clockwise as if powered by some invisible cosmic rebellion. This counter-rotation isn't just a visual oddity, it's a forensic clue pointing to cataclysmic galactic theft. The prevailing theory imagines a smaller galaxy, rich in gas but poor in stars, swooping in on a near-perpendicular trajectory. As the intruder plunges through the larger galaxy's disk, gravitational tides strip away its gas like a thief snatching a purse. But here's the twist: if the victim galaxy was orbiting opposite to the host spin, the stolen material inherits that backward motion. Picture two ice skaters colliding, one spinning clockwise, the other counterclockwise, with the first stealing the second's scarf mid-impact. The scarf keeps its original spin even as it's absorbed into the skater's outfit. Similarly, the captured gas settles into a retrograde ring, fueling star formation that perpetuates the backward dance for eons. Yet some counter-rotating rings refuse this tidy script. In UGC 5192, the ring orbits backward relative to both the disk and the galaxy's halo of dark matter, a cosmic pirouette requiring 3 separate rotation axes. This triple contradiction suggests something far stranger than a simple gas theft. Astronomers now suspect these systems may be remnants of a polar ring galaxy gone wrong, where the perpendicular ring's orbit destabilized over billions of years, warping into misalignment like a gyroscope winding down. Supporting this, ALMA telescope data reveals chaotic gas streams bridging the disk and ring, as if caught mid-tumble during a gravitational reconfiguration. The real enigma lies in how these backward rings survive. Physics dictates that opposing rotations should create violent turbulence, shredding the ring within a few orbital periods. Yet in NGC 7217, a counter-rotating ring has persisted for at least 2 billion years. High-resolution simulations reveal a possible savior, magnetic fields woven through the ring like cosmic rebar, their tension resisting shear forces that ought to tear the structure apart. It's as if the galaxy has stitched its rebellious ring in place with invisible threads, allowing the contradiction to endure against all odds. What transforms these twisted rings from curiosities to cosmic revelations is their power to expose dark matter's fingerprints. Their very existence proves that galactic halos aren't perfectly spherical. Their lumpy gravitational fields leave subtle imprints on gas motions. By mapping how counter-rotating rings wobble or precess, astronomers can reconstruct the invisible scaffolding shaping them, like deducing a sculptor's hands from the way clay spirals on a potter's wheel. Every backward whirl is a silent witness to forces we'd never see otherwise, spinning secrets into the void. Most cosmic rings shimmer with visible starlight or infrared warmth, but some blaze with far more dangerous energy. Across the universe, astronomers have discovered rings glowing fiercely in ultraviolet and gamma rays, emitting radiation potent enough to sterilize entire star systems. The galaxy NGC 7392 presents one of the most extreme cases. Its ring, pulsing with gamma ray, bursts 1 trillion times more energetic than sunlight, equivalent to detonating a supernova every hour for millions of years. What could generate such relentless fury? One explanation points to Wolf-Rayet stars, rare, monstrous stars that burn at temperatures over 200,000 degrees. These stellar furnaces blast ultraviolet radiation strong enough to strip atmospheres from planets light years away. In rings like that of the galaxy IC 2591, these stars cluster so densely their combined emissions set the entire structure aglow like a neon sign in the cosmic void. But gamma rays require even more extreme conditions. Here, scientists suspect hypernova explosions 10 times more powerful than typical supernova, launching jets of material at near light speed. When these jets plow through surrounding gas clouds in the ring, they generate gamma-ray flashes brighter than entire galaxies. Yet not all high-energy rings fit this explanation. The galaxy UGC 5701 emits a smooth, uniform ultraviolet glow with no trace of individual stars or explosions. This has led to wilder theories. Perhaps dark matter particles annihilating upon contact, releasing energy as they collide within the ring's dense gas. Alternatively, the ring might harbor a population of magnetars, neutron stars with magnetic fields so intense they twist spacetime itself, producing gamma-ray flares as their crusts crack under the strain. The most puzzling cases show energy patterns that defy known physics. In Hoag's object, gamma-ray detectors picked up rhythmic pulses exactly every 107 days, a cadence too precise for random stellar explosions. Some researchers propose these could be signs of a hitherto unknown phenomenon: quantum black holes evaporating in synchronized bursts, or perhaps cosmic strings, defects in spacetime's fabric vibrating like plucked guitar strings across galactic scales. What transforms these radiant rings from curiosities to cosmic keystones is their role as natural particle accelerators. Their extreme environments may be generating exotic matter we can't reproduce on Earth, hinting at physics beyond our models. Every unusual photon carries clues about how energy operates at scales we've yet to comprehend. Some ring galaxies present astronomers with a cosmic conjuring trick, a dazzling ring of stars encircling what appears to be absolutely nothing. These central voids aren't just empty, they're unnervingly vacant, as if something reached in and scooped out the galaxy's heart. The galaxy AM 064471 is a prime example, its luminous outer ring framing a darkness so profound it swallows even the faint glow of background stars. What could possibly carve such a perfect hollow in the fabric of a galaxy? One compelling suspect is a supermassive black hole gone rogue. Normally, these gravitational monsters lurk at galactic centers, their presence betrayed by swirling accretion disks of superheated gas. But simulations suggest that during violent mergers, recoil forces can launch black holes clear out of their host galaxies at speeds exceeding 2,000 kilometers per second. The aftermath might leave behind a sterilized core, a void where the black hole's gravity once hoarded stars and gas, now flung outward to form the glowing ring we observe. Supporting this, some void-centered rings show telltale scars, faint X-ray echoes hinting at a black hole's past activity, or stars orbiting phantom masses where the gravitational anchor once resided. Yet not all voids fit this narrative. The galaxy NGC 4622 presents a quieter mystery. Its central region isn't just devoid of a black hole's glow. It lacks the dense star clusters typical of galactic cores altogether. Here, astronomers propose an alternative explanation: resonance-driven migration. Just as Saturn's gravity shepherds particles into its rings, gravitational interactions between stars and dark matter could gradually clear the central region, pushing material outward into the ring over billions of years. It's like watching sand slowly drain from the center of an hourglass, leaving behind a hollow framed by what once filled it. The most perplexing voids defy both explanations entirely. In Hoag's object, the central region shows no evidence of past black hole activity or stellar evacuation, just an eerie equilibrium where stars simply never formed. This has led to radical proposals. Perhaps these galaxies originated in ultra-diffuse gas clouds so thin that gravity couldn't muster the density to ignite star formation at the core, leaving it perpetually dark while the outer regions condensed into a radiant loop. Others suggest these voids might be cosmic fossils, preserving the primordial conditions of the early universe where dark matter's peculiar distribution prevented normal galactic evolution from taking root. Whether sculpted by violence or forged in stillness, these vacant centers force us to confront how little we understand about the balance of creation and emptiness. They stand as silent reminders that the universe doesn't always build from the inside out. Sometimes, the most breathtaking structures emerge from what's missing rather than what remains. Some ring galaxies spin with such reckless velocity they should tear themselves apart. Yet against all odds, their stellar hoops hold firm. These cosmic speed demons rotate at velocities that defy basic gravitational math, where the visible stars alone couldn't possibly generate enough gravity to keep the structure intact. The galaxy NGC 7140 spins 30% faster than its observed mass should allow, its outer stars whipping around at over 250 kilometers per second, so fast that centrifugal force ought to fling them into the void. So what unseen hand grips these rings, keeping them from unraveling into chaos? The prime suspect is dark matter, the universe's invisible scaffolding. Most galaxies are thought to be cocooned within vast halos of this mysterious substance, their gravity dominated by dark matter's pull rather than visible stars. But ring galaxies like UGC 4597 take this to extremes. Their rotation curves graphs plotting orbital speed against distance from the center remain flat out to the ring's edge instead of dropping off as expected. This suggests an enormous, unseen mass distribution extending far beyond the luminous ring, like an iceberg with only its glittering tip visible. Some models propose these galaxies might be threaded with dark matter filaments in visible rivers of mass channeling extra gravity precisely where it's needed to sustain the breakneck spins. Yet dark matter alone can't explain the most extreme cases. The Cartwheel galaxy's outer ring rotates 50% faster than standard models predict, even after accounting for a generous dark matter halo. Here, astronomers have turned to more exotic explanations. Perhaps the ring is permeated by thousands of stellar mass black holes, their combined gravity bolstering the structure without emitting detectable light. Or maybe the galaxy's magnetic fields are stronger than imagined, acting like cosmic rains that constrain gas and stars to their frenzied orbits. In the galaxy ISO 383G76, polarized radio emissions reveal magnetic field lines so intense they could be providing the extra tension needed to stabilize the spinning ring, like invisible wires on a rotating space station. The real enigma lies in rings that vary their speed. NGC 766's western quadrant spins markedly faster than its eastern side, a discrepancy that would cause most structures to warp or fracture within millennia. Yet this galaxy has maintained its lopsided spin for billions of years. Some theorists propose an ongoing collision with an invisible dark matter subhalo, its gravitational tug selectively accelerating part of the ring. Others suggest we're witnessing the aftermath of a slingshot event, where a rogue black hole punched through the ring eons ago, transferring momentum to nearby stars like a celestial cue ball. What makes these hyper-fast rings so transformative isn't just their defiance of physics, it's how they force us to rethink the limits of galactic durability. They prove that structures we once considered fragile might be far more resilient than imagined, bound together by forces we're only beginning to map. Every impossibly swift orbit is a challenge to our models, a dare to look deeper into the darkness between the stars. Most galaxies age gracefully, their stars growing old together in cosmic unison. But some ring galaxies break this harmony, flaunting rings that seem frozen in time while their surroundings march onward. These mismatched stellar populations tell a story of galactic upheaval, where certain regions resist the march of time while others bear the scars of violent renewal. The galaxy NGC 2997 presents one of the most striking examples, its outer ring bursting with newborn blue stars while the inner disk glows faintly red with ancient suns, a celestial paradox that challenges everything we know about galactic evolution. How can a single galaxy wear such contrasting ages like celestial rings on a tree stump? One answer lies in the physics of galactic collisions. When galaxies merge, the shockwaves can trigger localized bursts of star formation, essentially resetting the clock in certain regions while leaving others untouched. In the Cartwheel Galaxy, the outer ring shines with stars less than 100 million years old, infants by cosmic standards, while the core harbors stellar relics 10 times older. It's as if the galaxy experienced a delayed adolescence, with star birth exploding in its outer suburbs long after its center settled into retirement. Yet not all age gaps stem from violence. The galaxy UGC 4597 showcases the opposite extreme, a ring of ancient red stars encircling a disk buzzing with youthful stellar activity. Here, the ring might be a fossilized relic of the galaxy's earliest days, preserved by some quirk of orbital dynamics. Picture an old neighborhood surrounded by skyscrapers. The ring's stars could be the last holdouts of a bygone era, their orbits shielding them from the gas inflows that fueled later generations of star birth closer to the core. Supporting this, spectroscopic analysis reveals these stars lack heavy elements, a telltale sign they formed from pristine gas in the universe's infancy. The real enigma arises when age disparities defy both scenarios. In Hoag's object, the ring and central core appear equally ancient, yet subtle chemical differences suggest the ring underwent a mysterious rejuvenation event billions of years after formation. Some astronomers propose dormant black hole activity, a long quiet core briefly awakening to blast radiation into the ring, shocking its gas into one final burst of star formation without visibly disturbing the structure. Others point to dark matter interactions, where invisible particles colliding within the ring release just enough energy to gently rekindle star birth like embers stirred in a fading fire. What transforms these age mismatches from curiosities to cosmic revelations is what they imply about galactic memory. They prove that galaxies don't evolve uniformly. Their histories can be written in disjointed chapters, with some pages deliberately torn out. Whether through violence, isolation, or forces we've yet to discover, these rings stand as living archives, preserving moments in time the rest of the galaxy has long forgotten. Among the most extraordinary theories about ring galaxies is the possibility that they don't just spin silently, they sing. Recent simulations suggest these cosmic hoops might generate gravitational waves or harmonic oscillations, rippling through space-time like the reverberations of a colossal tuning fork. While we can't yet hear these sounds directly, the mathematics reveals a haunting possibility. Some rings could be vibrating at frequencies so precise they'd hum a note 20 octaves below human hearing, detectable only by the universe's most sensitive instruments. The key lies in the ring's structure. Unlike chaotic mergers or irregular galaxies, a perfectly symmetrical ring undergoes orderly oscillations when disturbed. Picture plucking a guitar string. The vibration travels along its length, creating standing waves. Similarly, a gravitational jolt, say, from a passing dwarf galaxy, could set a ring oscillating in predictable patterns. Advanced models of Hoag's object show its ring might pulsate radially, expanding and contracting by fractions of a percent over millennia. These subtle motions wouldn't just warp starlight, they'd emit faint gravitational waves, ripples in spacetime predicted by Einstein but never before linked to galactic geometry. Detecting these ringtones would require next-generation observatories. The upcoming LISA mission, a space-based gravitational wave detector, could theoretically pick up such signals if a nearby ring galaxy experienced a recent perturbation. Even more promising are studies of resonant harmonics. Just as a wine glass shatters when exposed to a specific pitch, certain ring galaxies might amplify gravitational waves at distinct frequencies based on their size and mass. The galaxy NGC 7217, with its near-perfect symmetry, could be an ideal candidate, its oscillations potentially matching the sensitivity range of future detectors. The implications go beyond mere curiosity. If rings hum, their frequencies would reveal hidden properties like dark matter distribution with unprecedented precision. A high-pitched chirp might indicate a dense central core, while a deeper drone could betray the presence of an extended dark matter halo. Some theorists even speculate that ancient dissolved rings might leave behind gravitational wave echoes, faint traces lingering long after the visible structure has faded. It's akin to seismology for galaxies, using vibrations to map what lies beneath the surface. What makes this phenomenon so transformative isn't just the potential for discovery. It's the audacious idea that the universe might be playing its grandest structures like instruments, broadcasting secrets in a language of spacetime itself. As our tools evolve, we may find the cosmos isn't just a silent film, but a symphony waiting to be heard. Deep in the cosmic tapestry, astronomers have stumbled upon one of the universe's most uncanny tricks: ring galaxies that appear to have celestial twins. These mirrored pairs, separated by vast distances, are so strikingly similar in structure, color, and even star formation patterns that they defy easy explanation. The galaxy duo NGC 7101 and UGC 12059 presents the most baffling case: two near-identical rings, each with a faint central bulge, spiraling arms tucked inside their hoops, and matching dusty knots along their rims. Yet they're separated by over 400 million light-years. It's as if the cosmos pressed a cosmic stamp against the void twice, leaving perfect copies where none should exist. Could this be mere coincidence, a statistical fluke in an infinite universe? The odds seem impossibly slim. For two galaxies to share not just the broad strokes of a ring structure, but the same intricate details, like matching scars from ancient collisions or synced starburst regions, would be like finding two snowflakes with identical crystalline patterns. Some researchers argue these doppelgangers might be evidence of something far stranger: universal constraints on how galaxies can form. Just as raindrops take similar shapes because of shared physics, perhaps certain galactic structures converge toward identical blueprints when subjected to the same cosmic forces. The rings could be nature's preferred solution to specific conditions, like gravitational equations solving for the same variable in distant corners of space. But another theory tugs at the edges of known physics: the possibility of a deeper symmetry woven into the fabric of reality. In the same way fractal patterns repeat at different scales, could the universe have natural resonances that encourage specific galactic forms to recur? The paired rings ESO510G009 and letter 20179 support this idea. Both exhibit an unusual triple-layered structure, an inner disk, a glowing ring, and an outer haze of stars, all aligned at the same precise angles. Simulations struggle to reproduce such complexity through random collisions, hinting that some underlying principle might be orchestrating their matching designs. The most radical explanation lurks in the realm of cosmology's greatest unsolved mysteries. If the universe is infinite or part of a multiverse statistically, exact replicas of anything, including galaxies, must exist somewhere. Some theorists propose these mirrored rings could be the first observable hints of such repetition, cosmic breadcrumbs leading toward a staggering truth. That uniqueness might be the illusion and symmetry the rule. Yet for all their mystery, these galactic twins offer a gift, a natural experiment. By comparing their chemical compositions, star formation histories, and dark matter distributions, astronomers can isolate which features truly require identical origins and which are cosmic convergent evolution. Every mirrored detail is a clue, whispering that the universe's patterns might run deeper than we ever imagined. Not all galactic rings shimmer with serene symmetry. Some rage with storms that would dwarf anything in our solar system. These turbulent zones churn with superheated gas and dust, swirling in chaotic vortices that could swallow entire star systems. In the Cartwheel Galaxy's outer ring, Hubble spotted a maelstrom spanning over 1,000 light-years, a cosmic hurricane where gas densities fluctuate wildly and magnetic fields twist into knots. Unlike the calm elsewhere in the ring, these regions crackle with energy, as if the galaxy itself is weathering a tempest we can't fully comprehend. Are these storms cradles or graveyards? The evidence splits dramatically. In NGC 1291, turbulent pockets glow with the telltale signatures of collapsing gas clouds, the birth cries of protostars fighting to ignite amidst the chaos. ALMA telescope images reveal dense cores spinning deep within the turmoil, each potentially seeding future solar systems. It's as if the storm acts as a galactic nursery, its violent motions compressing gas just enough to spark creation. But contrast this with the galaxy AM064471, where similar turbulence coincides with eerie voids, expanses littered with the radioactive isotopes of dead massive stars. Here, the storms appear to be wreckage fields, stirred up by successive supernovae, blasting the ring's material like a cosmic blender set to obliterate. The most enigmatic storms refuse to fit either category. The galaxy UGC 4597 houses a vortex that pulses with rhythmic bursts of X-rays too orderly for random stellar births or deaths. Some researchers propose these could be dark matter weather systems, where invisible particles clump and heat surrounding gas through weak interactions. Others point to rogue black holes plowing through the ring, their gravitational wakes churning gas into frenzied patterns like submarines leaving trails in deep ocean currents. What transforms these storms from curiosities to cosmic keystones is their volatility. Their galactic pressure valves regulating how quickly rings convert gas into stars or scatter it into the void. A single turbulent knot might determine whether a ring blazes with newborn stars for eons or exhausts itself in a fleeting burst of glory. Nothing in the universe lasts forever, not even the breathtaking rings that define these celestial wonders. The fate of ring galaxies unfolds on timescales that dwarf human history, a slow-motion unraveling where gravity, time, and cosmic chance conspire to rewrite their stories. Some may dissolve into the cosmic background like sugar in water, their stars scattering into the void. Others might collapse inward, their elegant loops crumpling under the weight of their own revolutions. And a rare few could become something entirely new, galactic phoenixes reborn in forms we can scarcely imagine. Take the Cartwheel Galaxy's inevitable future. Right now, its iconic ring blazes with newborn stars, but simulations reveal this brilliance is fleeting. Over the next few 100 million years, the outer ring's gas, its star-forming fuel, will either be devoured by stellar bursts or blown away by supernova shockwaves. Without fresh material, the ring's glow will dim, its massive stars dying first and leaving behind a skeletal loop of red dwarfs and stellar remnants. Eventually, even these faint embers will drift apart, their orbits disrupted by passing galaxies or the gentle tug of dark matter. What remains may resemble nothing more than a disheveled spiral, its once perfect symmetry lost to time. Yet not all rings face such quiet dissolution. Galaxies like Hoag's object, with their stable, isolated orbits, might persist far longer, their delicate balance of rotation and gravity allowing them to resist disruption for tens of billions of years. These cosmic aristocrats could outlive even their spiral and elliptical cousins, becoming lone relics in an aging universe, but immortality comes at a cost. Without fresh collisions or gas in fouls to stir the pot, their star formation ceases entirely. The ring becomes a fossil, a beautiful but stagnant loop of ancient suns, their light fading into infrared obscurity as the universe expands around them. The most dramatic transformations await rings born from violent mergers. In systems like NGC 4622, where a smaller galaxy punched through the center, the future holds a second act. As the intruder's debris falls back toward the core, new instabilities arise. Some simulations show the ring buckling, its material raining down to form a chaotic inner disk while the outer regions puff into a diffuse halo. Others predict a grand rebirth, the returning gas triggering a fresh wave of star formation that erases the ring entirely, replacing it with a vibrant spiral or even an elliptical galaxy. It's a cosmic makeover, proving that destruction and creation are two sides of the same celestial coin. What truly haunts astronomers are the outliers rings that refuse to fit any model. The galaxy UGC 4597 spins with such precision that its structure could theoretically persist until the universe itself cools into darkness. Then there's ARP 147, where the ring's unusual tilt suggests a future of gravitational oscillations, slowly warping the structure into a three-dimensional helix over eons. These oddballs hint at undiscovered physics, perhaps dark matter interactions or magnetic field dynamics that could extend a ring's lifespan beyond current predictions. Ultimately, ring galaxies are more than just pretty cosmic quirks, they're time capsules chronicling the universe's relentless evolution. Whether they fade, transform, or endure, their stories are etched into the grand narrative of cosmic change. They remind us that even the most stunning celestial structures are fleeting brushstrokes in an ever-shifting masterpiece. From phantom rings that flicker in and out of existence, to galaxies spinning so fast they should tear themselves apart, the 30 strangest phenomena in ring galaxies reveal just how little we truly understand about the cosmos. Each one defies expectations, whether it's double-ringed bullseyes formed by cosmic skips across galactic ponds, or invisible halos of dark matter sculpting starlight into perfect loops against all odds. These aren't just quirks of nature, they're glaring holes in our cosmic playbook, screaming that the universe operates by rules we've yet to decipher. Consider the eerie silence of radio-quiet rings where Starburst should roar with interstellar static, or the time-lagged rings that pulse with starbursts like a slow-motion firework display. Then there are the warped rings, twisted by unseen hands, and the polar rings that orbit sideways like cosmic acrobats. Even more perplexing are the X-ray rings crackling with lethal energy, the backward spinning rings defying orbital logic, and the missing cores where galactic hearts should beat. Each phenomenon isn't just a puzzle, it's a doorway to new physics, a clue that dark matter, magnetic fields, or even hidden dimensions might be pulling strings behind the curtain. And that's the real magic here. These 30 mysteries aren't just curiosities, they're invitations. Every unexplained flicker, every impossible spin, every ghostly echo is the cosmos nudging us to dig deeper, to question harder. Maybe you'll be the one to crack the case of the phantom rings or untangle why some galaxies hum in gravitational frequencies we can't yet hear. The universe is far weirder, far wilder than we've dared to imagine, and ring galaxies are its way of whispering, "Keep looking." So what do you think? Which of these cosmic riddles blew your mind the most? Drop your thoughts in the comments. I'd love to geek out with you. And if you're hungry for more deep space mysteries, hit that subscribe button. The universe has plenty more surprises up its sleeve, and together we'll uncover them one mind-bending discovery at a time. Stay curious, fellow stargazers. The cosmos is just getting started.